So right now we are looking to balance number two. We have our chemical inventory underneath. All right, you can always still do the box. Now these lines are made for putting the coefficients down. All right, so when you get a combustion reaction like this, a combustion reaction is basically when you have a carbon hydrogen, all right, a hydrocarbon, and oxygen as your reactants, water and carbon dioxide as your products. Now, always try and do the balance of C's first. So we have two on the left. How many do we have on the right? Only one. So we got to multiply that one by two. So ugly two. I apologize for that. So when you whatever you multiply it by becomes its coefficient. That's the dude that goes on the line. Now, the reason I box everything is so we don't forget everything. All right, everything in the box that is behind the coefficient also gets that. All right, so this two not only applies to the carbon, now it also applies to the oxygen here. And that is this oxygen. We split it up in the inventory, all right, because they're in two different spots on the same side of the equation. So this O now down here has to get multiplied by 2, which gives us a total of 4 oxygen from that guy. All right, next dude, remember if you have an oxygen, an O2 like this, or an H2 by themselves, you try and save them for last. So let's go with the hydrogen next. If we have 6 on the left side and 2 on the right side, how do I get these two to equal a 6? You're going to multiply it by 3. I underline what I multiply it by because that becomes my coefficient. That gives me 6. So this 3 now doesn't just apply to this H here, but it applies to this O, correct? All right. One times 3 is? All right. So right now, let's take a peek. Our carbons balanced? We have 2 and 2. Okay. Our hydrogen balanced? 6 and 6. Oxygens, how many on the left side? How many total on the right? 7. Ooh, see now, because this is an O2, so this was the trick that I'm telling you about. If this doesn't come out to an even number, right? Trying to multiply this by a whole number you can't take 2 times any whole number and get 7. So what happens when you get this, all right? When you get an odd number of oxygen like this in a combustion reaction, what you're going to do would be, this is how they would show you. You would do like kind of this method, all right? 7 halves, or let me write it better. Just watch before you write down. 7 over 2. So to get rid of this 2, what would I have to do? In a fraction, how would I be able to get rid of that 2? Multiply by 2. Now, you can't just multiply this guy by 2. You would have to multiply the whole equation by 2. So, this is only going to happen in a combustion reaction where the oxygen on one side becomes the total oxygen on this side becomes an odd number, right? Because you can't do 2 times 3 because that's going to give you 6. You can't go 2 times 4. That's going to give you 8. So it wouldn't have worked. And then you would have to kind of keep playing around and changing these coefficients, and it becomes extra work. So the way to avoid all that is when you get this odd number, you would write it like a fraction and then essentially multiply the whole thing by 2. So if this is a 1, what would this become?
2, or is it just like?
Yeah, because you're going to get rid of that half on underneath. So by multiplying 7 halves by 2,
Like if it's not, like if the bottom number is a 2.
it's gonna be because in these combustion reactions, oxygen is one of the reactants. So you're always going to wind up doing that. And it's only going to be for this type of reaction. So that becomes the 7. 3 times 2 becomes what? And 2 times 2 becomes 4.
So do you have to have the parentheses or no?
I'm just showing you like why. But if you can remember, all right, remember that, you're good. So this reaction is now completely balanced, and we would say it's a what to what to what ratio?
2, 7, 6, 4.
A 2 to 7 to 6 to 4. Okay. So that one is, yeah, it's one of them, Johns, that is not easy to do like that. So let me see. Do we have another one on here that is going to do that? I don't believe we do, but there is a video that also kind of explains it, which we can put on or just kind of show for a second. All right. Did I get out of that? I did get out of that. Okay, hold on. Let me pause this. All right. I believe it is this type of reaction here.
Balance the carbon atoms first, then the hydrogen atoms, and then save the
So it goes the
oxygen
same
atoms
way. You
for
balance
last.
the carbons,
Oxygen
then the hydrogens,
is
and then
the
you would do the
pure element
oxygen
on the
last
left side.
for a combustion reaction like
If
this.
you run into a situation where you get an odd number of oxygens on the right side,
All right, so this rule only applies when you get an odd number of oxygen on the right-hand side. So when we would balance this, if we were to balance this, you have 4 carbon on the left, and you have 4 carbon. I'm sorry, you have. All right, can this stuff go away? It's 4 carbon, 10 hydrogen plus O2 yields CO2 plus H2O. So what would the coefficient need to be for this guy? Right? If we have 4 C's over here, what number would we need to place in front of this guy? What? A 4. All right. You have 10 hydrogen over here, so you would need to multiply the H over here, the H2, by a 5. Now that affects the oxygens. What is 4 times 2? So you would wind up getting, right, 8 oxygen from this guy. And what's 5 times 1? All right, 5. Now, right now, your carbon and hydrogen are balanced. You have 4 carbon on left and right. You have 10 hydrogen on left and right. But now you have 13 oxygen. So remember, when you get an odd number of oxygen on the right-hand side, what you're going to do is basically you'll write it as a fraction of 13 over 2. Right? It's always going to be over 2 because of this O2. And then basically multiply every coefficient by 2. This C4H10 had nothing there, so it would become a 2. And then they write it down here. All right. This gets rid of the half underneath, and it becomes a 13.
13 oxygen.
The 4 here would become a what? And the 5 would become a 10. So that will be how you guys balance a combustion reaction if, right, the total number of oxygen on the right-hand side, right, after we do our inventory, all right, if it comes out to be a odd number. That's the only time you'll ever have to worry about it. Otherwise, everything, guys, is going to be just kind of how we've been doing the last few days, okay?